Okay, this is an attempt to explain arithmetic series, and don't get series confused with sequence. They are related, they both start with SE, but a series is the sum of a sequence. I think there's a tongue twister in there somewhere. Anyways, on page 349 there is an explanation of how to derive the formula for a series, which is the sum of the related sequence, and the formula looks really ugly, and the derivation of the formula looks really ugly too. And if you want to follow that logic, you can actually watch the Khan Academy video, the first video on series and sequence, and Khan will explain how to derive it this way. I'm going to show you a different way to derive it that I think makes a little bit more sense. First of all, let's take a series here, and let's take a simple series: 2, 4, 6, 8, 10, 12, 14. I'm sorry, did I say series? That's a sequence, and that's a finite sequence. You can work with infinite sequences and come up with a series, like an infinite series, but that's calculus, and we're not going to deal with that here. So if we want to sum this, we can go through the laborious process of adding up 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14, and as we go through that and yada yada yada, we'll find out that it's 56. So 2 plus 4 is 6, plus 6 is 12, plus 8 is 20, plus 10 is 30, plus 12 is 32, plus 14 is, wait a minute, 6, 12, 20, 30, 42, 46, 56, right. So 56 is the sum of this sequence. But I'd like to call your attention back to something you learned in grade 7. If I have a bunch of numbers here and I want to find out the average, this is n terms, right? If I want to find out the average, I add them up and divide by the number of terms, right? So we take the sum over n equals the average. That probably sits very comfortably in your mind. If I find out the average of this, I add them all up and divide by the number of terms. So in this case, I would take 56 and divide it by the number of terms, 5, 6, 7, and I see that the average is 8. Okay, simple enough. Keep this in the back of your mind here. Let's take another series. 3, 6, 9, 12, 15, 18. Now, without worrying about this series business and sum business, I'm wondering whether or not I can calculate the total here, if I can calculate the average without knowing the sum. Well, the average, as you know, is going to be, in an all arithmetic series, the average is going to be the midpoint. In this case, it was the midpoint between the 2 and the 14, and it went right through 8, so we had an average of 8. Here, the midpoint, with the same volume of stuff on either side, is right in between 9 and 12. 3 terms on either side. It's because this is an arithmetic series, because the distance between 12 and 15, 15, 18, because those distances are all the same, the midpoint will define the average. So if I can figure out the midpoint, I can figure out the sum without ever knowing, without ever having to add everything up. So the midpoint here, you can eyeball it and you know that it's 10.5. So if I use this formula here, sum over n equals average, then I should know that the sum over 1, 2, 3, 4, 5, 6 over 6 equals 10.5, or 10.5. Simple algebra, multiplying both sides by 6, I know that the sum equals 10.5 times 6, which would equal 63. Now I found out the 63 here without ever actually adding these things together. What I did was I determined the midpoint, the average, and multiplied it by the number of terms, which is an application of this backwards. So if I can calculate the average without having to add everything together, I just multiply it by n, and I'm in business. So how do I do that? Well, the midpoint of an arithmetic series will always be the first one plus the last one divided by 2. 3 plus 18 is 21, divided by 2 is 10.5. 2 plus 14 is 16, divided by 2 equals 8. So the average can be calculated as long as you know the first term, which we know as a, the last term, which in the book is described as L, or lowercase l, and we have to know n, or the number of terms. So we take all this and we make a little formula that says a, the first one, plus l, which is the last one, divided by 2 gives us the midpoint, and the midpoint multiplied by the number of terms will give us the sum. Now this is exactly the same as what they have in the book, except they have it organized in a slightly different order. They say that S of n, which is the sum of all those terms, equals, and they put the 2 under here, so they go n over 2 times a plus l, which is the exact same thing. There's no difference between these two. I've reversed it so it sums on the left and that stuff's on the right, and the division by 2 goes under the n instead of that, but it still works out the same. So this is the formula that they come up with, and the rationale behind it is that you are calculating, just by knowing the first and last term, you're calculating the middle of the series, and the middle of the series is multiplied by the number of terms in the series to give you the sum. There's one more step that they take, and it's because you know that the last term equals the first term plus n minus 1 d. And that's what we learned earlier on sequences. We learned that the last term, which we used to call Tn, which was the last term, is this stuff. The first term, and that's the distance between the two. And this only applies to arithmetic series, by the way. So if L is unknown, if we don't know the last term, we can derive it as long as we know an and d. So these two formulas can actually come together where we have S of n equals n over 2 a plus l. And so instead of L and Tn are the same thing, by the way. This is just the last term. Earlier in the book it was described that way, and in the arithmetic series they start calling it L, which is stupid, but you know what? Sorry, I don't have my crapometer here, but that would just show that the book is moving once more to the left. So we're substituting this stuff in where we had L in that formula, and we get a plus n minus 1 d. And because we have two a's here, we might as well just call it 2a. So n over 2, 2a plus n minus 1 d. Like that. So the final formula then, it depends on what we know, which formula we will use. If we are given both a and l, we can use that formula. If we are given d but not l, then we'll have to do the calculation of d, and we'll use this part of the formula instead. 2a plus n minus 1 d. So that's if we know d but not l, that's if we know l but not d, and that will allow us to solve an awful lot of the problems that they throw our way.